Okay, so I think we'll get started. Looks like we've got quite a few people here, and this is always on a record for later anyway. So thanks for everyone for joining. We're here to give a demo of the work that we've been doing over the last few months on the prototype version of Libero. We set off on this task because we realized that there's quite a lot of architecture that needs to change in the previous version from the stack that powers eLife, and wanted to try out some ideas, particularly around things like versioning multiple languages and different data types so that we can support different types of data schema. And rather than wait until we had the time to go into this full on, we wanted to ensure that people were able to talk about the technology early and look at the technology decisions, and we'll be able to get some RFCs out. So we'll talk about the RFCs later, but we've basically posted a few on the Libero community GitHub repo, so they'll be there for your review over the next few weeks. But I suppose we should get on with our agenda. So today we've starting off with Chris, who's going to be talking about our data model and the architecture, and an overview of all the reasoning behind what we've been doing, an overview of that. And then we'll get a demo of a basic article going through and looking at how that appears in the dashboard prototype. And then slightly more in depth at some of the tools that are powering the dashboard behind it. And we'll upload a second article so you can see the versioning and all that side of things working. And then we'll talk in more depth about the data model and the concepts, how it's extensible, how it can work for your journal, and so on. And then I'll talk a little bit about the RFCs, how you can get involved, and what we expect to be doing next, including details of our community sprint that we're hoping to organize in mid-August. And then the remainder of the time, and we've got 90 minutes reserved for this, so probably won't take that long, but we've got plenty of time for questions and answers, delving a little deeply. And then, of course, we'll be available on Slack or email or GitHub or any other communication medium that you can find to get us. So without any further delay, I'll pass over to Chris, who's going to talk about the architecture.
Okay, so rather than compared to something you can just kind of get off the shelf and just run, we are looking at using a microservice-based architecture for Libero. This is based on what eLife has put together, and that currently runs eLifesciences.org. We feel that microservices work quite nicely because they allow you to encapsulate features into these separate applications, which kind of enforces a natural modularity rather than having to code in a particular style inside a monolith. This makes it really easy to extend, add new features, and then reuse existing ones. It also allows different peoples and teams to work on different parts completely independently, do it in parallel, and then release them whenever they're ready. In a monolith, there often is complexity still, but that gets pretty hidden. One of the criticisms of microservices is just they can get quite complicated, but this complexity is just obviously is visible rather than being hidden away inside. Because of this, how things communicate is kind of crucial for microservices, and they require strict definitions of how they're going to work so that you don't accidentally couple things together. So eLife has gone from running monoliths to microservice-based architectures. It's not the easiest task to do, but it has proved really valuable for the team in terms of the way we work and how we're able to deliver features. We feel that this is suitable for Libero, as having these actual smaller pieces can increase reuse. In comparison to downloading or running Drupal or WordPress or something, that is definitely simpler, and you can extend it with modules and stuff, but you do run into scaling problems, especially when we're trying to look at something like Libero, where we don't want to enforce how you use it. So we've gone and put together this walking skeleton, which is in no way production code and not complete. It's just meant to be an example of how Libero could work, how these bits could fit together. So we have a repo under the Libero namespace on GitHub called Walking Skeleton, which is a working project using Docker. So we've got a basic framework put together of a variety of applications, and then the communication methods that they're going to be using. So if I just zoom in a bit on this architecture, This is a bit similar to what we've shown in the past when we've been thinking about Libero, but it's evolved slightly and obviously now has working code behind it. So the core of this architecture is two different communication methods. So we've got an API, which allows for reading and updating content, either inside of Libero-based applications or from outside, and an event bus, which allows for services to monitor and react to data changes that are happening. So a basic pattern is that a service would listen for a specific event. So we know something has happened. It can go and fetch data through the API and then does whatever it needs to do. So this could be, if it's a search index, it'll be going to fetch the data about a new article and indexing it. Or it could be sending details about this article to PubMed Central or whatever downstream deposit. Yeah, so then we've got these applications. They're using these communication methods to interact. So to create an article through this, a HTTP request is made to the API. This is implemented by the article store, which internally does some processing. It's emitting events along the way, saying what it's doing, and then says what at the end to say it's been persisted. There's a public-facing journal application, so this is what the world would interact with to read your content. This reads data through the API. There's a dummy downstream sample, which we just called Crossref inside, which that listens for the article being ready, so it listens for the event, and then it emits its own event in response, just to pretend that it's performing some task based on that. Meanwhile, we've got a dashboard visible, which is receiving all of these events and is showing them. So you can see a history of what's happened. So these different services actually have no knowledge of each other. All they know about is this defined communication method and the contract, what that means. So the specification of what the API is and how the event bus works. They've got no knowledge of what's implementing them or what's going to be reacting to their to data changes that they've made. So so I'm going to hand over to Sean now, who's going to start going through a demo of this. So inside the Walking Skeleton repository, we have an examples bash script, which will run this through. You can bring up the containers by yourself, or this bash script is going to bring up the containers and then perform some basic tasks, such as creating a new article, updating an article, and then ultimately deleting the article. So yeah, Sean's going to walk through a bit of this now.
Okay, so I'm going to just switch over to my terminal now. It's several staged where we can stop in this script. So it's going to give you time to go and look at something. It's specifically meant to give you a chance to see what's going on, not just exercise each of the components.
Wait a second. Your terminal's not showing on the video. Are you getting it on yours?
Yes. I'm getting the terminal on Walking Skeleton folder.
Giorgio can see it. Okay.
Okay. Carry on, it might just be a few things. Yeah, might just be mine.
Okay.
There you go, it's updated now.
Okay, sorry. There was a bit of a delay there with the screen updating. So that might happen as we proceed. So if you feel that I'm talking ahead of something you can see, I apologize. So at the moment, I've just, you can imagine I've just cloned the repository and I'm just going to run the example script. So the first thing it's going to do is, as Chris mentioned, it's going to start the containers for you. So if you were playing with this sort of on your own using the Docker Compose file, you could obviously be doing this yourself, but this is kind of all encapsulated in this for you for this example. We can have a look a bit later at what it's actually doing, what it's actually starting, but it's going through and starting all of our required services. So we'll just wait for all these to come up. Now, okay, so at this point here, been notified, we're actually going to create an article. So if we have a look in our article store at the moment, this is our article store. So at the moment, we have no articles in it. So let's create one. So hitting the enter key will send a post request. This will be taken into the API. If we look at the dashboard now, you will start to see these events coming through. So to explain what's going on, so this is our dashboard. We're receiving the events for this run. So maybe familiar with that term as we use it now. So this is all under that ID, giving it a namespace or an identifier for this run and all these actions that are being executed. So just briefly going over a few of them, you can see that the article was submitted to the article store. It was then passed into Airflow to execute one of our workflows or DAGs, which we can go over in a moment. And what this does is actually extract the asset URIs from the article, which are currently private URIs, and it goes through the process of making them public. So it's simulating something you may want to do with an actual article in production. We then see that the updated article is redeposited back to the article store, and the last event is actually a sort of a simulation or an example to show that an external service has also received an event. So in this case, we've called it a crossref deposit to say that it's received an event. So going back to the example script, the next stage is to create version 2 of this article. So we've got the notion of versions included here. So we've got our version 1 stored. We didn't actually look at the article, so we'll just go back to that before we create the second version. So if we look at our journal now, we've got one article in the list. And you can see you've got the article data and also the now public image. This would have been private on first deposit. You can also see just down the bottom that we have support for other languages. So if we were to switch to Spanish, you can see the content changing. Not sure how many we've got on here. In Arabic, you can see the right to left change there. And this is built in from the ground up. So this was a major consideration from the start. Okay, so going back to the example, we'll create the second version now. So it's the same article ID. We've just entered this again. Now, the data you'll see when you actually look in the script, you can see the example data being given. So I won't go into the actual XML that we're submitting, but you can see that's in the source. Going to the dashboard now to see the status of our second run here. So you can see it's going through the same stages. I'm just refreshing the page to get the updated events at the moment. And you can see that's finished. So at the moment, being that we've only got one workflow being executed, it's not a very long process to submit it in. And if we go back to our journal, you can see that we've got version 2 here. Version 2 has just been added to the title just for clarity. Same article, but we've now got a version 2. So the next step in the example is we're now going to update version 2. So this could obviously be anything. We're actually going to update the image that is shown. So this will go through a very similar set of steps. We've got another run started off, and it's going to go through the same workflow. But the end result should be that we've now got a different image on that same article. So just have a look at the journal in a second. Okay, so I'll just click on this now updated article, and we now have a different image embedded on the article. Now, going back, the last step is just showing that we can actually just remove the article from the journal, from the article store, so it will no longer be accessible by the journal. So this still gets its own set of events being sent to the dashboard. Obviously, there's no workflow or anything this time. It's just a simple start and completed deleted article events. But you have a record of it here, so it's visible. And if we go back to the journal, there's no articles there. So getting to the end of the example, part of the exit procedure is just to stop all the containers. So you don't have to do any of the cleanup yourself. I wanted to go through possibly just the first step of the example again and just give a slight insight to what Airflow is doing when you actually go through this process, as you can get quite a lot of information from that. And I know it's, if you haven't used it before, it's probably quite an abstract thing you haven't seen working. So I'm just going to start the example up again. Whilst that's starting, Airflow provides you with an admin interface. So you'll be able to see all your different types of workflows. So I'll change my terminology now that we're in here. It refers to what we would know as a workflow as a DAG. So in case you're wondering what the naming convention is here, but effectively it's a very similar thing. I won't click on it just yet because I'm waiting for the containers to start up. Okay, so I'm just going to click on this DAG. So this is what we actually execute once an article has been submitted. So we've got various stages that we've set up. So we store the article data locally. We fetch the actual article content. We extract the URIs out of it. We download any assets that we need to from these locations. We then update the URIs and the content, and we then deposit it back to the article store. So what I'm going to do is I'm going to actually start the process now, and we'll come back to this page, and you'll be able to see them going through each one of these tasks. So I started the submission there. So if I'm refreshing this on the right-hand side, you should start to see in a moment the task starting to update. Try again. Okay, so we can see that the first few have actually been run and completed successfully. This one here is still running. If I refresh this, we should see them all completed. Obviously, this is quite quick. If you had quite long running tasks, this might be something you wanted to look into to get some more information if the dashboard either wasn't enough for what you're trying to investigate, or whether you're trying to just ascertain what if an error has happened. You can dig into that a bit more. So aside from that live view whilst it's going on, you then have the option to look at things like how long everything took, where your times are. You can see any bottlenecks in what you're doing. This tree and graph view become quite useful as well if you have branching decision trees, depending on if a task starts or fails, or you've got concurrent tasks. So you can get a lot of information here, and also you can drill down into each one of these to get more information. So you can click on your task, go to the task instant details, and you can get the log that was generated from this task. You can get all the variables that it was handling. So there's a lot of information for each task that's been executed there. And I think we'll probably, when we get to sort of question time, we can go into more of that if we need to, if there's interest for that. So I think I won't bother going through the rest of the example for the second time, but I'll pass you back to Chris.
All right, I'm going to talk now a bit about data modeling inside Libero and how we think this could work. So there's two forms of messages that I mentioned earlier happening. So there's the messages around the API, so HTTP request and response, and then events, so the things that are going over the event bus. We did various experimentation into what suitable form could be. eLife up to now has been using JSON for most of these, but we feel that XML is probably a better format, since a lot of these are documents as opposed to data. Data is far better in JSON, but yeah, documents, XML is better, mainly because of things they can do inline elements and that type of thing. We looked at various schemas for these, so how can we describe what the body of these messages are going to be, because the kind of communication protocols could be reasonably strictly defined, so you need to be able to trust what data you're getting through in a message. We compared various schemas. We found the RelaxNG provides a really nice extensibility model. This is lacking in other schemas, so things like the more common XML schema, also known as XSD, and up to now we've been using JSON schema, but this is just missing entirely from it. So, yeah, I mean, these schemas are important because you can do machine validation with these messages, but also they are a form of documentation as well for developers, so you can understand exactly what you're going to be receiving or you have to send. We really do want to allow people to come up with their own structures. We don't want to be in the business of defining one. That fits in with kind of the ethos of Libero, and that it is you build your own system out of these bits. So we looked in various ways of doing this. We're thinking that the actual kind of core required part should just be as small as possible. It should be the absolute bare bones. And then from there, people can use this to build up their own schemas. We can provide extensions for common requirements. So, simple stuff like paragraphs of text or author details or reference lists. But there's never going to be a requirement to use these. If, say, you've got an archive of content that just doesn't fit this model at all, that's perfectly fine. You can go ahead and extend it with your own custom things. Obviously, the slight downside to here is you would then have to code for this. Libero namespace code can understand all the Libero namespace extensions, but if you've got your own custom things, then yeah, you're going to have to write some code to probably present it or process it or whatever you're doing with it. We don't really want to be reinventing the wheel in terms of how these schemas work. So as far as possible, we do want to try and base them on existing standards. So just JATS, especially JATS for R, TEI, even HTML. And definitely try and think about clear mappings between them where appropriate. It's not going to be possible across the board just because of the flexibility of things like JATS. You've got multiple ways of doing the same thing. But as far as possible, we'll try and come up with clear mappings. And ultimately, since you're building up your own schema, it should always be possible to embed external formats in this. So you could probably just embed JATS inside this and it would work. Again, you're probably going to have to code for it, although maybe that could be provided as library. So in the walking skeleton we've got so far, the event bus message format we've used is far more basic than we know it's going to need to be, and is actually JSON rather than XML. But just for the purposes of the skeleton, that was good enough to get us going. The API format we've got is a little more fleshed out here. So I'm looking at the walking skeleton repo. I'll just zoom in slightly for you. So inside here, we've got a schemas folder. This just contains some very basic core schemas. So inside data, this refers to some RelaxNG schemas. So if we go to inside article, we find these are two. So we split article into two APIs actually. So there's two different endpoints. So we've got one for front matter, one for body content. You can imagine you could add more and add your own custom ones. So we have a very base core Libero schema for this that is minimal. So for front matter, I won't go too detailed into RelaxNG's syntax, but I'll just try and describe what it's doing here. it defines a root element for this XML document called front, which is namespaced under the Libero namespace. And inside here, there's very few requirements. So it's literally setting an ID element, a title element, and a language attribute. And that's it. All of this in the Libero namespace. And that's the minimum requirement for an article. Of course, you probably want more than that. So we need to be able to extend things. I'll just give a mention to this RelaxNG define element. This is the key for its extensibility model, because it allows you to add them in later on. This in comparison to something like XML schema, where you have to explicitly say this thing can be extended. At this point here, it doesn't know that it's going to be extended, it's just possible, which is really powerful. So we probably, in our article, we probably want something like an abstract here. So there are some example extensions. So if we go back up a couple of levels, yeah, there's an extensions folder. Has a bunch of these are purely examples. The actual elements and attributes and stuff aren't just meant to be representative, not actually what we're suggesting. For individual extensions, so we've got an abstract extension. So what this is doing is adding a new abstract element inside the front matter content. So if you want to use this, you just enable this schema. Likewise, you could then, if you need to do something custom, you just follow this exact format. You can add anything you like to it. Okay, so in the skeleton, we also have this project called API Dummy. Now, this is just a static version of the API. It's not actually used by that example script, but it has some example schemas we'll come up with for a few different publishers, and then some sample articles for these. So if we go inside here, and we look inside the public folder, there is the schemas directory. So this contains example schemas for a few publishers, including eLife. So if we go and look in here, so this is where we've got an example of what an eLife article front matter schema could be. So if we look at this, we are defining things in the eLife namespace because it's our eLife schema. But the first thing we do is pull in that Libero front matter schema. So that's the core. So we've got the Libero base elements there. We then want to extend it to include some things, including things like the abstracts, but also some of these other extensions that are there, such as DOIs and MathML. We also, in this case, just want to include some custom eLife things. So we've come up with a eLife namespace digest element. So this follows the exact same way of extending that these extensions do. So very simply, we could add in custom things to it. So we can completely make this schema our own, either by using shared Libero namespaced schemas or using our own under our own namespace. So with this data is now our own. In the same way, body content. So we have the eLife namespace body schema that extends the Libero namespace one, enables the bunch of extensions that we need our content to include, and then add some custom bits and pieces. So in this case, adding a custom attribute. Down here, adding some custom inline elements. Also inside the API dummy, if we go back up to the top, there's this data folders. This contains some sample articles for each of the publishers that matches their own schemas. So this one is the eLife article. So we've got a eLife front matter. So it uses the eLife front matter schema. Uses Libero as the default XML namespace, so there's no prefix, but also uses the eLife namespace with an eLife prefix. So these are all Libero namespaced. So we've got things, so the root front matter, the ID, the DOI, title abstract. These are all enabled through those extensions. And then down here is our eLife digest element. So this article allows us, so we validate this against our own schema. It's our data. We can include what we like in here. This same principle exists for all these other publishers. So there's a bit of variety between them. So we just took a few sample articles and tried to work out a bit of what extensions might they need to enable, and then what custom things would they need. So that described how these messages themselves could work. The other part of the API is the actual HTTP endpoints themselves. So for describing that, we looked at using RAML, which is similar to the more common open API that was formerly known as Swagger. But we found it to be more flexible in terms of what it can do. And Open API appears to be a little limiting, especially when it comes to this Libero idea of building your own thing. It's also quite JSON focused. It doesn't really work. It doesn't work with XML at all. And it's even their own forked version of JSON schema. They are resolving that, but it's still, yeah, it doesn't meet what we need it to do. So using RAML, we've looked at following the same approach of providing some standard schemas. So if we nip back up to the root and into this schemas project, the other part of this was called API. So this provides some standard RAML definitions. So in this case, we've got a kind of core part called base, which just, there's a couple of really simple things, such as defining the error format. So these are going to be really common things across all Libero APIs. But in terms of actually defining any endpoints, this doesn't do that because it's your API. When it comes to something like the articles store, which was the thing that the example script was interacting with, we have created a schema for that. So this other file is called articles. So this is not tied to the article store code. This is the contract that is defined that application then implements. So you could actually replace that implementation with something else. So maybe you need to change it. You need to add in a lot more functionality and for some reason want to do it in a different language or something. As long as you implement this contract, it's still compatible. And then any client libraries or whatever under the Libero namespace can then still read it. So yeah, this is basically just defining some. I won't go too details into how RAML works, but it's just defining a few endpoints. So a base list of articles, and then information about how to get a single article, potentially delete an article, create a new article. So these are the endpoints that we were using through the example script. So this is a base contract of how an article store API will work. What this isn't going to do is actually define a schema for the body of the messages. So when you're reading information out of it or creating a new one, that's your relax-ng schema. That's not defined here. So we have an example in here called API doc, which is an example of a publisher's API schema based on all that. So inside here, we have a file called api.raml. That is just a made-up example of a Libero-based eLife API. All this actually does is it fetches the article store contract twice and then includes it with slightly different things. So this is just stating that we have an endpoint called /articles that implements that article store contract. And then we provide it with our schemas. So we've got the relax-ng schema for the front matter, the relax-ng schema for the body content, and then a sample document for that. We also then have a separate Wikipedia Articles endpoint, which is just using the same thing. However, that has a different schema. So in this case, it's a Wikipedia front matter and a Wikipedia body content. Likewise, different sample articles. But in this case, it's actually extended the article store contract by adding a new query parameter to the root listing, and then also add in new endpoints. So the base article store contract defines the ability to get front matter and body content. This adds in a separate references endpoint. So we're kind of adding new content. We've then used a library called RAML to HTML to then display this. We looked at various options. The tooling isn't brilliant, but this is the best one we've found so far. That then turns this RAML into human readable documentation through HTML. So this is turned, so we've got our kind of two. So we've got our kind of articles API and our Wikipedia articles API that includes all these different endpoints. So in case of articles, these are all pulled in through the article store contract. But if we go and look at something like the front body endpoint, this is then including the eLife schema as we set it, and also includes the eLife example document that we set in it. So we've been able to supplement the article store contract with our own information. Likewise, with the Wikipedia articles one, we extended it slightly with custom query parameter and a new endpoint. So if we look at the listing endpoint, we now have this offset query parameter, which is the custom one we added to it. And we also have this references endpoint, which is completely custom to this. So it's an extension to it. Yeah. Mostly this just serves as documentation at the moment. I mean, we've done this in eLife, and we have found it really valuable, especially when you've got lots of people working on it and someone coming in. It's to actually have something you can view through your browser is quite powerful. The RAML and Relax combined with Relax and G are completely machine readable. We are looking for tooling which can help with kind of test cases for implementations. So you can imagine you could run an article store just to check it validates against what the contract is, especially since the contract and implementation are decoupled. But we haven't yet found anything suitable for this. But yeah, it's definitely on the lookout, and it might be something we could end up rolling ourselves.
Okay, thanks, Chris. So great demos there, lots of things that we've covered. So we'll not leave it too long until we can get some questions, because you might have want to clarify some understanding on there. What I wanted to just cover first, though, was, Chris, if you can go back to the Libero community repo, we've posted in there some requests for comments. So the quickest way to go to that is into community, and then inside that text there, you'll see there's a link that takes you to a nice little search that gets you anything that's tagged with an RFC. And we've added a few on there, one of the main ones being the RFC around the high-level architecture, which Chris looks like opening now. So this is basically what we've been talking about, all the things that we've discovered by doing this, some stuff that we've discovered by talking to other people. We've been showing this at various stages to other interested developers as well, and this is kind of where we've got to. So open these RFCs. We want to try and be quite quick with ensuring that we get a consensus on these. So if hence why we wanted to get them ready for this call, have this call, and then get everyone's eyes on them in the next couple of weeks. So we'll probably put a time limit on and say sort of mid-July. We'd like all comments on there, depending on how the discussion's going, so that we can say, right, that's how we're going to build it, and then we'll be in a good state to start building stuff in earnest. So that's the first bit of the timeline. The next bit is that in August, we're planning on having a community sprint. So I've already spoken to people at Gujarati and Hindawi about potentially joining in for this, kicking off in our Cambridge office on the 13th of August for 2 days together. I did originally call this 2 days for a workshop, but it feels like we won't be sat around with presentations and whiteboards. More, we just get together to help start this, start the build of the MVP of Libero. Before that, we hope to have our minimum viable product broken down into stories using the stuff that we've been working on for information from all the people involved in the community. Some of the stuff that Gujarati have been doing before us as well, finding out what needs for various publishers are. So our product team here are working hard on that, and that will be represented as a list of issues on a project in this Libero repo. I'm not entirely sure where yet, but if you keep an eye on the Slack, we'll let you know exactly where that's going to be. So once we've got a prioritized list of stories to build, it's again a case for this 2-week sprint that we're planning to all get together, decide some of the more final parts about the architecture, the infrastructure, the ways of working and so on, and then get on with building it. Our plan is to get everyone working together for at least those 2 days, hopefully for the remainder of that week and the following week, so that we get reasonably far working as a cross-organizational team, and then people can go on and hopefully continue that in their own time. At eLife, we're committed to working on Libero from then until the rest of the year, at least, where we're hoping to get the MVP up and running, and then we're hoping to launch the International Journal of Microsimulation on Libero, and then we'll look at what to do next, what the next priority is. There's a few other journals really interested in getting involved, and I know there's people wanting to go and get something built for themselves, and we'll probably assist with that as well. So this Libero is going to be the main focus for the latter half of the year at eLife. So I just wanted to let you all know about that, and I'll also invite you to come and comment on the RFCs. So I think, unless there's anything else from the team here, we'll try and use this tool. So apologies for the technical issues with this tool. We're trying to support other open source tools by using Jitsi. It also helps us record things on YouTube better than some of the Google tools we've been using. So hopefully we can get going. So one of the issues over here is a bit of feedback. So Peter's got his headphones on. All right, let's see if we can. If anyone's got a question, try unmuting yourself and letting us know.
You can mute and unmute.
Okay. Yeah, or you can just type it in the question box.
Hi, Paul. I don't know if you can hear me or not.
I can hear you.
Okay, cool. I was just going to start by asking a quick question on airflow and whether or not, from the work that's been done. Do you see that as being the approach that you think should be taken and used moving forward? And are there pros and cons in your view with regard to why you would use that over what's currently been used in the existing Libero platform?
Yep. So, one of the things we wanted to move away from with the existing platform is the reliance on AWS tools, and that uses simple workflow. So, what is something that would work in that way? Also, with it being another open source tool, we've got the extra features, the way that it's built, the community that's behind it are really supportive. So, we're hoping that new features that will grow out of that will be beneficial to us as well and beneficial to the Libero community. But in terms of the execution and the actual Python that runs, we're hoping that some of that can be reused. There's obviously some caveats that if we're using a different data model, that obviously the code needs to be refactored to fit that. But there's some things that will be standard, like downstream deliveries to places like Crossref and to different aggregators that will always be the same at some point. So we'll be able to reuse that. And the reason we chose Airflow is because it allows you to run Python in small steps. It's a very similar idea to what we've got now. We're just using a different orchestration tool.
Okay, thanks. That makes sense. And I guess, obviously, just in terms of its status, are there any risks with using it, do you think, or
its status in regard to it being an open source tool? I think it's still used inside. It's built by Airbnb. It was still being used by them. It's been adopted by the Apache Foundation, so it's one of the more stronger tools in the ecosystem at the moment. So yeah, that was a consideration for us. Sean's got something to add.
Yeah, I just wanted to say as well that I did a lot of the work trying out some of the other options as well, and just in terms of my feedback, you don't have to buy into certainly in terms of down to the code level, you don't have to buy into Airflow as much as you would something else. You are literally just executing Python functions, and you have a very small wrapper around that, which is nice. But they also have quite a nice way of extending what you need to do with their sort of plugin system. It's slightly harder to do with some of the other options. But we haven't had to do much to get it to where we need it to be, really.
Okay, so another question I'll just repeat for what Hindar we've typed in here. Give it a start for us. How do we extend jobs on Airflow? Is that possible? And will they be stored as a library in Libero?
Okay, so there's massive amounts of opportunities for expansion in this part. So it really just does depend on your needs. So in terms of extending it, yes, the concept of a DAG is just a series of tasks, and these don't have to be they can really be what you want them to be. So if you can start other DAGs from inside, so if you wanted them to have knock-on effects and to trigger other workflows, you can do that. Inside each actual task, you can do whatever you want to do. You can do whatever you can do in Python. And in terms of storing the history of tasks, you've got the opportunities to do that. And it really just it's very flexible in that way. So there's not that they have no set way of really doing things. They just give you the tools to do it. Really, that's how I saw it.
Is Python the only option?
Python's the only option in order for the code execution.
Right.
Yeah, and that's because the core of it is itself written in Python as well.
Yeah, but there are quite a few like integrations and sensors that with other systems, so you can integrate other systems that building the languages. But yeah, the code execution is Python itself, isn't it?
Yeah, so you'd need to you can obviously your task itself. You have your standard sort of Python operator, they call it, which is execute some Python in this task. But you also have a bash operator, so you could do things that you might want to execute in bash. And you've also got, as Paul said, off-the-shelf sensors. So do something when something happens in an S3 bucket, for example, or do something when an event happens in a database. All these sort of things, and you have the opportunity to write your own.
Yeah, it was that larger ecosystem that attracted to us. It actually first came onto our radar when we were looking at this. Coincidentally, we were also looking at data pipelines and ETL work with a data consultancy, and they suggested this would be a good tool for that. And we thought, well, it sounded like a similar tool for this. So it might be one of the tools that we use for some of our open source data pipeline work, which will be coming later in the year. Okay, any other questions? Nothing more in the chat. Anyone on the voice? Oh,
so I just realised there was another part to that question. In terms of our Libero, they're going to store some of it in a Libero library. That was going to possibly be the plan. So in terms of customized parts of Airflow that we would use, we would have it just in a library that you could install, so other people could use that as well.
Yeah. So, and the extension of that question from Hindawi as well, will Airflow be a single point of failure? Like, if it is down, will data and processes be lost?
To a point where, at the moment, we're structuring it so the Airflow instance we're talking about here is effectively owned by the article store. So the article store receives an article and it knows that it has an instance of Airflow it can offload a task to. You could say it's going to be a point of failure. It's not going to execute what you need it to, but it's only another part of the system.
It's also built in a way where the data is decoupled from the app, so you could scale it out like you would any other app, having multiple either warm or warm-cold nodes in a data. Sharded.
It only knows how to just to post information to Airflow. It doesn't really care how big or small the instances are behind it.
And another question. So how is state managed in Airflow? Is it stored in the article store?
No. All the article store knows is that if it has the opportunity to pass an initial request to trigger a DAG in an Airflow instance. Apart from that, it doesn't communicate with it at all. It doesn't know about each of those task steps. Airflow can send its events to the event bus on its own. That was actually the one customization that we needed to do to Airflow, was to enable your tasks to communicate with our event bus. And the state is well, it has two parts. So it has a Postgres database in which it can store its sort of task instances, its historical data, and it has a Redis layer in which the tasks can pass information between each other if they need to.
Yeah. So in terms of continuing from where it left off, if it disappears, it's
yes. So it has a history of what it was doing at that time. Yeah.
Yeah. And they also say, great, so it can use the event bus as a store. That sounds good. Yeah, I mean, with the event architecture that we've got, you could effectively build your own event store that'd be replayable, attached to it to consume every message. That's quite a common architecture and this sort of stuff. We've not done that in the prototype, but yeah, things like restorations, dead letter queues, all that sort of architecture from large distributed systems should be quite pluggable for this sort of thing. So, and again, that's part of the ethos, the architecture, the philosophy that Chris talked about earlier, that you can make this as big, resilient, and complex as you like, or keep it as simple and small as you like, because the number of people we've been talking to range from very tiny single person publishers to huge publishing organizations and every stop in between. So hopefully this helps it to be flexible and compatible with different needs. So no more. I've got a question in the room.
No, I wanted to elaborate. Hi, I'm Giorgio. I wanted to elaborate on the event bus question to avoid misunderstanding. There's an RFC open on the technology that backs the event bus, which is RabbitMQ. It is a persistent event bus in the sense that in case there are failures on the nodes that provide this service, the state can be kept because RabbitMQ supports that, and it could be clusterized so that it's not a single point of failure. It is not a long-term storage solution. The persistent it provides is related to messages that have to get from one service to another. But we are not envisioning it so far as a place where, like Kafka, where you could replay a lot of events to reveal the state of another store. More just as a tool for services to be aware of what is happening elsewhere.
Thanks, Jojo. Okay, anything else? I've got a question from Ross. Is the API gateway no longer using Kong? Are auth and other plugins no longer required?
So in the skeleton, what we've done is just put in plain old Nginx, and it just proxies requests through. We're imagining we probably would still recommend Kong. I mean, it might be worth just re-looking at the see if there's any new kids on the block. But Kong's worked well for us in eLife so far. So that is, as it stands, that's what we would recommend. But yeah, it's still something to be looked at. And we didn't worry about that too much with skeleton, as that's a architecture we're familiar with.
Elaborating on this, there is a bit of a shift in the sense that the eLife API was also meant for external consumption, while the API of the working skeleton so far is only meant to serve the front ends rather than being directly consumable by other organizations, other downstream services. So some of the authentication that Kong provides, for example, may not be needed, but there are other very common features like rate limiting we found useful. So if there's no need to shift away, we could reuse it in this context.
Yeah, it might be that if you have a need for an externally facing machine readable version of your data, which is one of the use cases we have explored, that the Kong is a good choice for that. But for now, it's, as Giorgio says, it's a client for the front end to be able to consume its data. Okay, any other questions? All right, doesn't look like it. Okay, so if you be willing to go and just check out those RFCs that we've put on there, and then we can chat about them further in the Libero Slack. If you've not seen the link for the Libero Slack to join it, or you've not managed to join it at all, then just contact me via email, p.shannon@elifesciences.org, or get in touch with any of us through whichever other means you normally do. Thank you very much, and we hope to see you next time we all meet up. Thank you.